Hello everyone. In this video I want to talk to you about doing a review for the test that we have here for the part 2 of solving quadratics. I'm going to be doing one problem for each topic in this review. So you're going to be able to see how I solve the problem or how I think about the problem for every one topic that we covered in this unit. Okay? You can always comment below and let me know if you have any questions about any one particular problem or steps. And yeah, let's begin. So these are the topics that we've discussed in this unit: quadratic formula, using the discriminant, quadratic and linear system of equations, solving real-world problems with systems of equations, and then solving quadratic inequalities. Okay, so I'm going to go in detail into every one of these, and I'll have an example. I'll have 5 total examples, one for each topic. Let's begin. So whenever you're being told or asked to solve for x, you have 2 options that we've discovered or spoken about in class. The first option is factoring, aka Lopez approach, where we cross multiply and add them up and see if they add up to the middle. And then the second option is the quadratic formula. Okay, my first option will always be, personally, I will always prefer to do the factoring approach, always, where you find the factors and you make your 3 columns and figure out how to solve. That's always going to be my first approach because personally I think that it's a faster method and a more simpler approach to do these problems. But sometimes that's not possible. As you see here, if I do my 3 columns, I have x times x, and then I have negative 1 times 1. When I cross multiply these, they don't add up to the middle. And there's no other combination of numbers that I can use to actually add up to 5. So when it doesn't work that way, when factoring doesn't work, when Lopez approach does not work, this means that it's not factorable, which means the numbers are not going to come out to a nice number. Therefore, we want to be able to focus on using the quadratic formula. And the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac. Everything divided by 2a. This quadratic formula will allow you to solve for any type of problem, rational or irrational. Okay? Whenever you do factoring or Lopez approach, they're all whole numbers or integers or even nice fractions. But when it doesn't work that way, we know we're going to be getting some irrational numbers or weird decimal solutions. So, when you're solving this problem, you first want to be able to identify your a, b, and c, right? A equals 1 in this case, because we have a 1x squared, right? We have ax squared plus bx plus c. So a is 1, b is positive 5, and c is negative 1. Now all I'm going to do here to solve for x is I'm going to substitute a, b, and c into this formula and then simplify the work. So I get x equals negative b. I'm going to put everything in parentheses. Plus or minus the square root of b squared minus 4 times a times c. I want to put everything in parentheses because I need to be careful with the negatives, having a negative b or having a b squared or the 4ac part. Everything here times a negative, we got to be careful, and the calculator will take care of a lot of this work for us. Once you substitute everything in, you can actually type everything that you see inside the parentheses, inside this part, inside the square root. You can put it all in Desmos or in your calculator so you can get one nice answer out of that. Okay? So use Desmos as much as possible so you can simplify your work. Here I'm going to get x equals negative 5 plus or minus the square root of 29 divided by 2. How did I get this 29? From simplifying this in Desmos. 5 squared is 25, 4 times 1 is 4, negative 4, minus a negative 4 turns into positive, so 25 plus 4 comes out to 29. Now, because the 29 does not have a nice square root, a whole number that we can pull out, 5 times 5 is 25, and 6 times 6 is 36. 29 is somewhere in the middle, which means this is going to be some decimal between 5 and 6, like 5 point something. We're not going to be dealing with decimals, so we don't want to round or any of that stuff. So whenever I cannot pull this out, this becomes an irrational solution, because then I cannot simplify the square root anymore. I leave it the way that it is. It's better to leave it in this fraction form, irrational form, than to put it in decimal form and then round and then be off in our solution. From here, we can identify that we have two possible answers. There is a plus and a minus, which means I can break this into two parts. And I'll change colors for this. I can change it to x equals negative 5 plus radical 29 over 2. And I can break it down to the x equals negative 5 minus radical 29 over 2. And those are my two solutions. Now, if this problem was factorable and you did the quadratic formula, these two solutions would have been nice fractions or nice whole numbers in the end. If it's not factorable, then that's when you're going to get these types of solutions. So when you're solving for x, you want to make sure you put everything on one side of the equation so you can properly identify A, B, and C, or so you can have your three columns depending on what method you want to go about. But solving for x means you're looking for the x-intercepts. That's really what we're interested in. That's what it means to solve, to find the solutions. You're looking for the x-intercepts of this quadratic, okay? So, everything has to be on one side, and you're solving for x using either factoring or quadratic formula. Let's go on to the next topic. This next topic is about the discriminant. Now, the discriminant will help us identify how many solutions does this quadratic have, right? How many solutions will we have? How many x-intercepts can we predict? We don't want to know where is the x-intercept. We don't care if it's at -4, at -10, at +3, or at 0. We just want to know how many are we going to have? How many intersections can we predict? So, one thing you can do is you can put it on Desmos and just look at the graph. How many times will it cross, right? You have three possibilities. You have the possibility. Here, let me change colors here. I'm going to do three graphs real quick. You have three possibilities when it comes down to how many solutions you can expect. You can expect two solutions, right, where it crosses here twice. You can expect one solution, where it touches it right there once. Or you can expect no solutions, where it doesn't cross the x-axis at all, right? Now, this is graphically how you would see it on Desmos for two solutions, for one solution, or no solutions. How can we predict this using the discriminant? The discriminant, right, is another fancy word for using what's inside the quadratic formula. The quadratic formula, I'm going to remind you here, I'll put this in red so we can stand out a little bit, is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. This piece of the quadratic formula is known as the discriminant, that part that I highlighted. If you solve this piece, right, just the shaded region of the quadratic formula, it will tell you if you have two solutions, one solution, or no solution. So if that part inside the square root, let's go back to this color. If that part of the square root, the b squared minus 4ac, is greater than 0, we're going to have two solutions, because we're going to have a plus or minus something. If the part inside the quadratic, or the discriminant, if this piece is equal to 0, we're going to have only one solution. And then lastly, if b squared minus 4ac, if the discriminant is less than 0, so a negative number, this is how you know that it's not going to have an x-intercept. So how do you figure out this b squared minus 4ac? Well, you have to make sure you first go and find your standard form. Identify a, b, and c in your equation, plug it into the formula, and then whatever number you get, if you get a positive number out of a, b, and c in this equation, you know you're going to have two solutions. If you get a 0, exactly 0, you're going to get one solution. And if a, b, and c, when you put in the formula, you get a negative number, you know you're going to have no solution. So you have the Desmos option where you can graph it and you can figure out what it looks like, and then identify if it has x-intercepts, or you can use the discriminant, this piece inside the square root of the quadratic formula, to determine which one of these you have. Okay, next topic. Quadratic linear systems of equations. So what we're looking for here, right, in a quadratic linear system is you're going to have two equations that are going to get graphed. And we're trying to figure out three different possibilities. We're really looking for the intersection, is known as the solution, right? So whenever you graph this, you can always put these two equations on Desmos, graph them the way that they are on Desmos, and Desmos is going to provide a picture for you. And then from the picture, you can answer these questions, like find the solutions of this system. What they're asking for here is the exact coordinate points of the intersection. So you would go here, and you would click that point, and you would tell me the solutions. Depending on how many solutions you have, 1, 2, or 0, you would tell me the exact location of the solution. This is where they're going to intersect. This is where you can expect them to cross each other. Or if they don't, then you would say there's no solution because they don't intersect at all. So type them into Desmos, type in these two equations into Desmos, and depending on the equations, you might have to zoom in or zoom out to see exactly where it crosses. Click on those points, and they will appear as coordinate points on your calculator. The next question you can encounter is, how many solutions does it have? At this point, we don't care about the location. We're just looking at the picture. How many times does this line intersect with this quadratic? And from the looks of it, you can just count how many times it will intersect. Remember, it can intersect 0 times, 1 time, or 2 times. So my options here will always be 0, 1, or 2. And then lastly, you can also get asked, is a specific point a solution to the system? So when you graph it on Desmos, you identify, is that point one of these two? And if it is, then you say yes. And if it isn't, well, then you say no. Depending on if that's the point of intersection. So quadratic linear systems of equations, we're using Desmos. You can always do this by hand, and I showed you guys how to do it by hand. You can always go watch that video, the recording that we did in class of how doing it by hand. But the best route to do for this type of problem, when you're looking for the solution, is put it on Desmos. Graph it. Graph it and figure out what it looks like. Zoom in, zoom out, and figure out if it intersects. Desmos calculator. Okay? All right, now that we spoke about this, I want to talk about how this belongs into the real world. And this is when we started talking about the word problems. Now what we're doing here is we're working backwards. Given this picture, can we determine which system of equations gave us that picture? Now you can always graph A, B, C, and D in Desmos and see which one best matches, or we can figure out what some of these equations can expect, right? And what we can do instead is we can say, I know that the quadratic will have 3 parts of the variables. 3 variables we're looking for, A, B, and C. And the line will have y equals mx plus b. Okay, those are the two things we can look for, where this is slope and this is your y-intercept of the line. Now with the quadratic, this is going to become your y-intercept, your starting point where it crosses the graph, and this is always going to be, as we discussed in class, a negative 16, because the parabola is always pointing downward, right? It's a negative a value. It's always going to be pointing down. Gravity is 32, so when we take half of 32, we are left with that. Now this piece in the middle is about the initial velocity. You rarely have to worry about that. If you know A and you know C, you can identify the parabola. But if it comes down to it, B sub 0 is the initial velocity of the rocket or whatever it is that you're throwing into the air that's going to fall down eventually. So let's get into this, right? When you look at this problem, I know that the A value is, here, let me change colors real quick. I know that the A value is negative 16. So I look at the 16 values, and I can already eliminate A and B because those two are not negative. They're positive, which means the parabola is pointing up, and that's not the case here. So now we go down to C and D. The next thing that I do is I look at the y-intercept. Where does the parabola begin? And to do that, I look at this part of the graph. Where does the quadratic cross the y-axis? Well, that point right there, as a guesstimate, that estimate is about 100. So that's my answer choice, instead of 250. Now, if these two equations were identical, the next thing we would have done is I would have gone down to the line, y equals 30x and 30x, and identify the slope and the y-intercept of this line. Where does it cross the y-axis? And then make my selection from there. But all we're really doing here is we're trying to see if we can figure out a real-world problem. Can you formulate the system of equations? Can you come up with the equations that resulted with this graph? All right, let's try our next one. For this topic is solving quadratic inequalities. If you look here on the left, this is where we're having the inequality symbol and we're determining where to shade, right? Open circles have parentheses, brackets have closed dots. Whenever it's a less than type of problem, we're always shading between the two numbers. When it's greater than, it's always going to be shading away from the two numbers. So really the only thing you need to identify here are what are those two numbers? What are those two dots? How do we find those two dots on the number line? And it comes down from solving the quadratic. Now, in order to solve the quadratic, we need to make sure that we always put everything on one side of the equation. As I mentioned in class, that is the biggest difference between Algebra 1 and Algebra 2. In Algebra 1, you spent a lot of time solving linear equations, like this. And the purpose of those linear equations was to isolate the variable and move everything else to the other side. Well, with Algebra 2, when we're solving quadratics, you're doing the opposite. Instead of isolating the variable and moving everything to the other side and leaving the variable alone, what we want to do is move everything to the same side. Move everything to the location where the x squared is positive. So what I want to do is when I'm looking at this, like where do I move everything? Do I move it to the left or do I move everything to the right? And honestly, the easiest thing is always just make sure that the x squared is positive. So if x squared is positive on the left, move these two to the left. If the x squared is negative here, negative x squared, then I would have moved the x squared to the right to make sure that the x squared is positive. So I'm going to move it to the left by moving the x to the other side. Since it's positive x, I'm going to do minus x. And I have x squared minus x greater than or equal to 30. And then I move the 30 to the other side. So since it's positive, I do the opposite. And I have x squared minus x minus 30 greater than or equal to 0. Now, from this sign alone, the greater than or equal to, I'm already expecting this to be my solution. That's what it's going to look like at the end, because it's greater than or equal to. My answer is going to look like that. My number line is going to look like that. This is what I can expect. Everything else is not going to matter. Now, I just need to find those 2 points. I just need to find that number and that number from here. So we pretend it's an equation. How do we solve this quadratic? Well, factoring is always my first option. So I have x times x. And here I have 6 times 5. It gives me 30. Now, because the 30 is a negative, I'm going to put this as a negative 6. Because when I cross multiply, I have 5x and negative 6x. And that adds up to a negative x. Right? 5 minus 6 is negative 1. So my factors come out to x minus 6, x plus 5. Sorry. X minus 6, x plus 5. Set that equal to 0. And now I set each factor equal to 0. And I'm just solving for a quadratic here. Right? I got x minus 6 equals 0. X plus 5 equals 0. So when you solve, you move the 6 over to the right. You get x equals positive 6. You move this to the other side. X equals negative 5. Those are the 2 points on my number line that I am looking for. So when I do my number line, I basically match it to the picture that I decided it was going to be. This is negative 5. This is positive 6. Because we have greater than or equal to, the dots are going to be closed instead of open. They're closed dots. So I fill it in here at negative 5, 6. I'm basically just copying the picture that I have, right? Because it's greater than, I'm shading away from the solution instead of in between. And now I write my solution, right? I'm going from negative infinity to negative 5. There's a union, and it goes from 6 to positive infinity because there's 2 shaded regions. At infinity, it'll never reach there, so I will always have a parentheses. But because these are closed dots, I'm going to put brackets around the 5 and the 6. And if you think about this, look at how exactly identical this looks to this. The only difference is that these hashtags or pound symbols represent the numbers that you found. Boom, boom. So if you actually have all of this on this left side in your notes, you can use that on your test. You just have to solve the quadratic, put everything on one side. When you solve the quadratic and you find your 2 points, you got yourself the rest of your solution. I hope this helps you prepare and review for your test for this quadratic parts 2 of inequalities. If you complete the review, you will see questions like these as well in the review. If you have any questions, please just let me know. I hope you guys are doing okay. And as always, I will calculate later.